Now let's work some problems. So the first problem is to develop X bar chart and R chart. So here we have data of contents of a 6-ounce bottle of aftershave. So we have sample 1 and there are 6 bottles and the content of those 6 bottles are given here, and this is sample 2, sample 3 and sample 4 taken in succession. So we have the sum for each of those samples. So X bar then is 35.7 over 6 is 5.95. 36.36 over 6 is 6.06, and then 35.76 over 6 is 5.96, and then 36.18 divided by 6 is 6.03. Now this X double bar then is you add all of these up, 5.95 plus 6.06 plus 5.96 plus 6.03, and then there are 4 of these, so divide by 4 and that gives us 6.0. Okay. Now range, so you look at the largest value, so this is largest minus smallest, so that is R. So the largest value here is 6, smallest value is 5.9, so 0.1. Next one, 6.3 minus 6 is 0.3, then 6.06 minus 5.9 is 0.16, and 6.1 minus 5.96 is 0.14, and you average these and you get 0.175. Now sample size. Okay. Now this is one thing that students must be very careful about. You need to distinguish between number of samples and sample size. So sample size is how many observations are collected from each sample. In other words, to find X bar value, what do you divide it by? Divide the sum by. So which is 6. So sample size is 6. Now if you go to sample with this sample size, let's go to the table 6.1. This is in page 241. Okay, so for 6.483 is the value of A. Then for 6, D sub 4 is 2.004 and D sub 3 is 0. Now the formula for the X bar chart is, so the formula, let me write, formula is X double bar plus or minus A sub 2 times R bar. So A sub 2 times R bar is 0.483 times R bar is 0.175, that is 0.0845. Then the lower control limit for X bar is X double bar minus 0.0845, which is 5.9155. The upper limit is 6 plus 0.0845, so that will be 6.0845. Now the R chart lower limit is D sub 3 times R bar, which is 0 times R bar is 0.175, so that is 0, and then D sub 4 times R bar, which is 2.004 times 0.175 will give you 0.3507. So these are the limits. Now let's plot these points here. First is XBAR chart. Okay, let's do XBAR chart. The midpoint, the target value is 6. Then the lower control limit is 5.9155, so that is approximately about here, and the upper control limit is 6.0845, which is about there. So this is X double bar 6.0. This is lower control limit of X bar equal to 5.9155. So that's that. Okay. Then this is the upper control limit of X bar equal to 6.0845. So now we need to plot the individual X bars. So from here, the first one is 5.95. So 5.95 is about there. It's going to be slightly approximate since we're doing this by hand. The next one is 6.06. So 6.06. So this is sample 1. Sample 2 is 6.06. And then 5.96 for sample 3. So 5.96. Okay. And then 6.03 for sample 4. So 6.03 would be about that. So now you connect the points. Okay. Now all the points are within the control limits, so we can say XBAR chart is in control. Usually you will have like 20 or 25 samples, but we want to keep the amount of computations reasonable, so we have only 4 samples. So XBAR chart is in control. Now let's draw the R chart. Again, R bar is 0.175. So 0.175 is about there. And then the lower control limit is 0. And the upper control limit is 0.35, so about there. So this is R bar 0.175 and upper control limit of R is 0.3507, lower control limit for R 0. Okay. So now we plot the R values. The first one is 0.1, so samples, first one. The second one is 0.3, it's about there. 0.16 is the next one. And the fourth one is 0.14, so that will be about there. So connect. So again, all points are within the control limits, so you can say R chart is in control.